Oops. All right, everybody. So we're in the last lecture, we were talking about loops in Bash. And so we saw there's a while loop and an until loop. So today we're going to talk about the for loop. When we're done talking about for loops, we're going to loop over the command line arguments, and then if there's time remaining, we're going to move into the array, talk about arrays. So there's no list type in Bash. There are arrays, but there's no lists. So if you wanted to write a for loop over the elements of something like a list or an array, it's not obvious how you do it. If you read the Bash documentation, there is this term list that shows up though. And so when Bash says list, it simply means a sequence of white space separated strings, right? So A space B space C space D is a Bash list that has the elements A, B, and C in it, and D. Okay. So a list is just a sequence of white space separated strings. You can write a for each loop over such a sequence, right? And so in Bash, that looks like for, and then a variable name, in, and then your list of, or your sequence of white space separated strings, semicolon, do, and then commands. The do can be on the next line. If it is, you don't need the semicolon. So for example, there's a for loop that counts from 10 down to 0. And each time through the loop, well, it doesn't actually count from 10 down to 0, right? You have a sequence of white space separated strings. So 10 space, 9 space, 8, and so on down to 0. This for loop iterates over each string in the list. Each time through the loop, I refers to the current string that we're visiting in the list. So this loop simply prints out the numbers 10 through 0, on one number per line, like that. If you don't like writing the semicolon do, just put the do on the next line without a semicolon like that, and you'll get the exact same thing. I guess I should explain what the semicolon is doing. Like that. So the semicolon is Bash's command separator. And so the for loop is actually, oops, sorry. So that is the for command, and then that is the do command. So the do command forms the body of the for loop. And so that's why you have to, that's why you, if you want to write everything on one line, it's semicolon do. If you don't want to write it on one line, then the do goes on the next line and you don't need the semicolon. Now, when to get a list of stuff, you can remember all of the Bash expansions, right? So all of the Bash expansions are all. Most of the bash expansions are capable of producing a list of strings. Right. So for example, word splitting will generate a list of strings. So there is my string, right? Notice it's got lots of spaces in it. Sorry, lots of spaces, right? So a bunch of spaces here, and a space between all the words. Everything's double quoted though, right? So if you were to write, so to get a white space separated list of strings, given str, right? You can simply have bash word split that string. Okay. So remember, if you word split that string, you get the word this, then you get a space, and then you get is and a space, and a, then space, and string, and then a space, and then one space, right? And then with, and so on and so on and so on. Right. So if you write your for loop like that, you get each word that is in the string like that, right? But this depends critically on the fact that this that was not double quoted. Right? Remember, if you double quote that thing, word splitting doesn't happen anymore. Right? So double quotes suppresses word splitting. So if you were to write the loop like that, you just get the string. Right? So now you've got a list made up of one string, right, which is str, and you get that printed out like that. Right? Now you might say, well, hey, look, those spaces all disappeared from the string that you just printed out, right? But you just told me that that use of the that variable expansion there prevents word splitting because you double quoted it. The answer is yes, that was double quoted, but when I printed the string, I didn't double quote the string when I printed it. So now you get all of the spaces preserved. So it's tricky, right? This the double quoting in bash is tricky. Here, right, if you want to print out all the individual words, you have to remember not to double quote that use of str, right? And now that works the way you want it to, right? If you accidentally double quote it, or if you intentionally double quote it, right, then the loop only runs once and it processes the entire string. Right? If you forget to double quote here, right, the word splitting now happens on the string, and you now get the message. This is a string with words separated by spaces with only one space between each word, right? And if you really wanted to preserve the spacing, right, you'd have to do something like that, right? So tricky, right? Not all arithmetic expansions don't produce strings with spaces in them, right? But the other expansions can. So file name expansion produces a list of 0 or more file names, right? So star.txt will match all the files that end in .text, right? And so that produces a list of file names. If I look at all of the scripts that end in sh in that particular directory, there's more than one, so I should get a bunch of file names printed out here, and I do. Right. So that works there. Right. Now the problem with file name wildcard expansion is that if the wildcard doesn't match, so if the expansion doesn't produce any matches, the expansion doesn't happen, and you just get the string that was used for the expansion. Right. So for example, in that directory, I know there's no files that end in PDF. Right. So if you run this particular loop, you might expect this loop to print nothing. Right. Unfortunately, it doesn't. Right. So that expansion here fails because there's no files that end in PDF. Right. And so the expansion never happens, and you just get the literal string ./scripts/loops star PDF. Right. So this can be a potential source of errors. Right. You don't recognize the fact that your directory may not contain any files that end in PDF, and you are expecting it to have a bunch of files or one or more files that end in PDF. You end up with an incorrect result, right? Your loop runs once when it shouldn't, which is unfortunate, but that's the way it works in bash, right? So before you write that kind of loop, make sure there actually is a file that ends in PDF in that directory. right? Otherwise, you end up with this hard to find, this strange bug or potential bug. Right, you can imagine if you try to do something with all of the files in that directory, right? So there could be some command here that does something with that PDF file, right? When that command tries to do something with that PDF file, it's going to fail. So remember, brace expansion will also produce a list of strings, right? So that brace expansion there produces the strings 10, 9, 8 down to 0. So that will also print 10 through 0. And command substitution can also produce a list of strings, right? So here, the sequence command is able to generate a sequence of numbers or letters, right? So that's the starting number of the sequence. That's the ending number of this. Starting number, ending number. That's the step size. So this will also produce a sequence 10, 9, 8, 7 down to 0, right? And that also prints 10 through 0, one number per line. For a simple loop like this, you should not use sequence, right? So don't use that command. That box tells you why, right? So the reason you shouldn't do that is because this is a command substitution right here. The way that command substitutions work in Bash is that your current shell starts a new shell, runs the command in the new shell, gets the result, shuts down the old shell, and then uses the result. Right. So that process of starting a new shell to run a command is more expensive than you need to write a loop that counts from 10 down to 0. Right. There's lots of other ways that you can do this without using a command substitution. So you'll see online, there's often many examples of writing loops using SEQ. Generally, there's usually a better way to do it. Okay, and here's another example of this is a better example of a command substitution to do something. So in the previous lecture, I showed you how to use grep. Right? So the grep command searches a file or files for a regular for strings that match a regular expression. So I'm going to search that file for all occurrences of the word if. Right, so I'm searching my script for all occurrences of the word if. So for all if statements in that script, I'm going to pipe that result to cut. Right. In cut, I'm going to grab the first field where all of the fields are separated with a colon. And so this is going to give me the line numbers where the string appears. Okay. I'll remove the pipe in a second to show you what you get if you don't have the pipe in. Right. And so that little piece of Bash prints out the line numbers in this file where the keyword if appears. If you don't use the pipe, I delete that. You get a mess, right? So the reason you get the mess is because grep prints out the entire line, right? That contains, so it prints out the line where the word if appears, and then it prints out a colon followed by the rest of followed by the line, right? That line contains a bunch of spaces in it, right? And so you're getting word splitting here when you echo line number. You don't have if you're not using the pipe to print only the line number, you have to quote line number to get anything. Oh, still doesn't work. Sorry. Where is the split happening? Oh, the word splitting is happening here. Is there any way to do this properly? What happens if I quote this? See, I teach the course and I don't even know what's going to happen when I do this. All right, let's see what happens. Oh, hey, that's better. Okay, that's what I wanted. All right, so I guess you have to quote both of them in this case as well. Right. So I only use cut there. So I'm using cut there as another example of a pipeline and another example of using cut to do something to process some text. All right, if you just want a counting style loop, then the easiest way to do it is with a C style loop, right, or a Java style loop, the Java style counting loop. Right. So the for loop in Bash looks exactly the same as the counting style loop in Java, except you use double round brackets and you don't need any variable. There's no variable type. Right. So that for loop there works the exact same way as the corresponding for loop in Java. Right. So, for example, right, if I want a loop that counts down from 10 to 0, I start out with I being equal to 10. Right. The loop runs as long as I is greater than or equal to 0. Each time through the loop, decrement I by 1. Right. And so there's your counting style loop. Right. If you want a counting style loop, generally this is the easiest way to write it. Right. Don't use a sequence to do it. Right. Similarly, don't write out 10 space 9 space 8 space 7. Right. Just use the counting style loop. It's a lot easier to do. And so there are your for loops in Bash, right? There's a for each loop. The for each loop iterates over a list of white space separated strings, right? The counting style for loop works more or less like the counting style for loop that you see in Java. All right, any questions about for loop? Okay. Command line arguments. So it's very often the case that a program will accept more than one command line argument. So for example, you might have a command that accepts a list of files, and you're going to do something with each file. And so you don't know how, well, so you don't necessarily know, or you don't really need to know how many command line arguments you have, right? You just want to do something with each command line argument. So there is a way to loop over the sequence of the command line. There's a few ways to do it. So remember what a parameter, remember what a parameter is in Bash, right? So Bash Bash says that any variable that has a funny name, so a symbolic name, is called a parameter. Right? And so, believe it or not, they reuse the asterisk yet again. So the asterisk is also a parameter name, right? So it's the name of a variable that means something. And at, or the at symbol, is also a parameter name. Right? And so both of these things expand to the positional parameters, right? So $1, $2, $3, and so on. Right? I'll tell you in a second exactly what they expand to. Right? When you're looping over the command line parameters, you almost always want to use at. So I guess I'll tell you what star and at mean. So these are parameters. So if you want their value, you need to put the $sign in front. Okay, so it's unquoted, $star and $at. Right, so both of them expand to $1, $2, $3, and so on. Right. So if your command line arguments have no spaces in them, then that's just a white space separated list of your command line arguments. Right. And now you can process that with a for each loop. If they have spaces in it, you have a problem because now you've got it's going to look like you have extra command line arguments. Right. So if $1 is X space Y, right, then when you process this unquoted, you have two arguments X and Y rather than the quoted string X and Y. Right. And so the quoted $at expands to $1 quoted, $2 quoted, $3 quoted, and so on. So you almost always want to use the quoted $at. Right. That's normally the correct thing to do when you're processing command line arguments. The quoted $star also exists. And I've never come up with a use for this particular thing. So what $star expands to is all of the command line arguments. Oops, sorry, 3 ... quoted. Right, so the individual arguments aren't quoted. Right, all of them are put into all of them are treated as one giant string that happens to be quoted. You almost never want to use that. And I've never been able to come up with an example where you would use that. Okay, so that little program, that little script there will iterate over each one of your command line arguments. Right, so for each argument, or whatever you can call this whatever you want, right? For X in, quoted $at do, right? So that's going to let you process the first command line argument, then the second, then the third. right? So this is going to print out $1 and then whatever that argument is, and then $2 and whatever that argument is, and so on and so on and so forth. Right, each time through the loop, don't forget to increment I by 1. So there's, I'm going to call the script. I'm going to pass in one argument, and then a second command line argument that's all quoted. Right, so that has 2 command line arguments. Okay. $1. Oh wait, 3. There's a third one. Sorry, it's because I'm zoomed in. So there's another one down here. Right, so 3 command line arguments. The last 2 are quoted. So there's $1, there's $2, and there's $3. Right, your 3 command line arguments. If you unquote that $at, you'll get. Where is? So I'm just going to go in and edit this. I'm going to forget to re-edit it, and then next year when I do this course again, it's going to barf for each. So A, B, X, Y, Z. Oh, sorry. Right. So now notice that if you don't quote the $at, right, you get the unquoted arguments, right? And so that one, when you process it, it looks like 3 separate arguments, X, Y, and Z, right? And so now your script thinks that the third command line argument is X, the fourth is Y, and the fifth is Z. That's actually misleading. The third command line argument is X, Y, Z, but when the loop processes it, it thinks it's X and then Y and then Z. Right, so your script knows there's 3 command line arguments. The processing there fails and thinks there's 5. Okay, so the bad for each, actually I could have just run that one. So the bad for each script does not quote the $at, right? And so that's the one that produces the incorrect results. Okay, the other common way to process the command line arguments one at a time is to use a while loop, and then use the command called shift. So the shift command shifts the command line arguments to the left by n, where n is some integer value, right? If you don't pass in n, then shifts each command line argument to the left 1, right? So that means $2 becomes $1, $3 becomes $2, $4 becomes $3, and so on and so on and so on. So shift or shift 1 shifts the values of $2 to $1, $3 to $2, and so on and so on and so on. Right, and so the way that you use shift to process all the command line arguments is the following. You use a little while loop, and you loop as long as the number of command line arguments is greater than 0. Right. Shift is interesting. So it causes number. It causes a number to decrease by 1 each time you shift by 1. It causes a number to decrease by 1 each time. Okay. So while the number of command line arguments is greater than 0, right, I'm just going to print out the first command line argument. Then I'm going to shift all the arguments, right? And so the second command, next time through the loop, the old second command line argument becomes the first command line argument, right? So the second time through the loop, the second command line argument gets processed. It's always $1, right? Because it gets $2 got shifted to $1. Shift again, so the old $3 now becomes the old third argument now becomes the first argument, and so on and so on and so on. And so there's the script that processes those 3 command line arguments using a while loop and shift, right? And it does the exact same thing. Yeah. Yeah. No, it doesn't unshift that loop. Yeah. Yeah. So you end up losing all of your command line arguments. That's So it destructively removes command line arguments. That's right. It also changes the value of $number, right? So you no longer know unless you created a variable to store the original value of number. You don't know the original number of command line arguments anymore either. So both of those techniques are common. I think the while loop is probably the most common, the while with shift. If you look online, that's probably the most commonly cited answer for processing the command line arguments. Okay, another example of using a loop, another somewhat common example of using a loop is to read a file one line at a time. So everything in Bash basically revolves around processing text files. Very common. It's very common to come across a text file where each line corresponds to to one piece of information, right? So you'd like to read the file one line at a time. If you want to do such a thing, then the standard or the common way of doing it is like that. Right? So you use this command called read, right? With a redirection. So the read command reads one line of text from standard input. Right? So it's expecting you to type it in and then press enter. Right? If you want to get your information from a file, you use a redirection instead. But notice this is a very funny redirection, right? So the redirections you've seen in the course before, right? You had some command that you wanted to run, then you had the less than arrow, and you redirected the input from some file, right? The funny thing here is that the redirection happens as part of the loop, right? So the while loop isn't actually a command, right? The redirection from the file sends the contents of the file to whatever command is sitting here, right? Whatever command is being used as the condition for the while loop, right? And that looks really funny the first time you see it, right? When you sit down and think about it for a while and process exactly what it is it's doing, it starts to make a little bit more sense, right? So contents of the file being redirected to the command used as the condition for the while loop. And so you can read each line of the file using read. So that argument there is the variable that read will store the result in. Right. So read one line, storing the result in there. Right. The -r. So the -r is there to treat the / character as an ordinary character rather than the escape character. Right. If it's not there and you have a / in the thing that you're reading, it's going to treat the / next character as an escape sequence, which you usually don't want if you're reading something in from a file, right? So imagine if your file has one line of your file looks like A, then /B for some reason, right? If you don't put in -r, read will treat that as though it were the escape sequence /B, which I think is the bell. So it might ding, but anyway, I don't know. I don't know for sure, right? So that's what the -r is sitting there for. Okay, so read the exit status of read is 0 unless an error is encountered or if it reaches the end of the file, right? And so that's why. So we're using the exit status of read to control the loop, right? As long as read is able to successfully read something from the file, that value is 0, which means the loop runs, right? And it processes the line that was just read. Right, so that's the variable that read is, that is the variable that read is reading into. You're allowed to have more than one variable, which is neat. So I think there's an example somewhere. So we'll get to that in a second. Okay, so imagine your script, you are trying to process a file that contains information about students in a course. Right, so I've got student number, comma, last name, comma, first name. Right. So I can process that file one line at a time using read. Right. So there's the exact loop that I just showed you. Right. So if I read each line of the file one line at a time, I should basically print out the contents of the file, and that's what we get. Right. All right. So the first few lines of a file of many file formats is some sort of meta information about the file. Right. So the first line in this particular file is giving me information about what each field on each line contains. Right. I want to ignore that, so I don't want to process that line. Right. And you can easily ignore that line, right, by checking does it start with the pound symbol? Right? How do I check if it starts with a pound symbol? Well, I can use a regular expression. Right? So does the line start with a pound symbol? And if it does, ignore it. Right? So in other words, ignore it so I can continue. Right? Remember, continue stops the current loop iteration, goes to the next loop iteration. Right? Just like it does in Python or Java. If the line doesn't start with a hashtag symbol, then go ahead and print out the line. That's great. So now I just get the student numbers, last names, and first names. Okay. Now, if you want to process each one of these fields individually, you could do something like split that string on the commas, right? So you could fiddle with IFS, use word splitting to split on the commas instead, right? But read is able to read into more than one variable at a time, right? So I'm going to use the IFS trick to force read to split that line for me. Okay. So remember, IFS is the variable that stores the characters on which word splitting should occur. Normally, it's the space, the tab, and the return and the new line character. I can set it to the comma, and that will cause read to split wherever the comma occurs. Right. So read also uses IFS to perform splitting of lines. So when I read, instead of using one variable to store the result in, I can use 3 separate variables to store the result in. Right? Any one of these variables that are unused, they just become empty. They just become the empty string. Right? So for example, if read can only read in one thing, then only student number gets assigned to. Right? If it can only read in 2 things, then student number and last name get assigned to. And if it can read in 3 things, all 3 variables get assigned to. If it reads in more than 3 things, then the extra things don't get assigned anywhere. Is that true? No. If it can read in more than 3 things, then I think all of the extra ones get stored in first name, if I remember correctly. Right. And so this version will be able to process the student number, last name, and first name for us. Like that. Right. So now I can do by fiddling with IFS, I can force read to split the string for us. This is handy if you've got a file where the information is stored in a standard way, right? In this case, it's comma separated. Right. Finally, I guess the very last part here. Right. So notice what I'm doing in the script. I'm remembering what IFS is here. Right. I'm changing IFS here so I can split on commas instead of spaces. And then for the rest of the script, right, I probably want any command or word splitting to occur on spaces again. So I have to set IFS back for the rest of the script. This is common enough that you can restrict the scope of IFS to the while loop as follows. Right, and so this example here, IFS is changed only for the duration of the while loop. Right, and so after here, after the loop is done, IFS is returned back to its original state. Right, and so this also does the same thing as the previous script. It's just you don't have to fiddle around with setting and remembering what IFS is. And so there's an example of how to read a file one line at a time. You'll probably see a question involving something like this on the next assignment. All right, so that's loops in Bash, right? You've got an until loop, a while loop, and a for loop, right? And 2 forms of the for loop, right? The for each loop iterates for each string in a sequence of white space separated strings, right? And then you've got the counting style loop, which is the normal loop that you would write if you need some sort of indexed looping, right? Which we are going to do with arrays. All right, any questions on loops? Okay, so the next notebook is the array notebook, and then there's only one topic after that, and we're done with Bash. And we'll move on to the C part of this. Okay, so Bash has arrays. The arrays are integer indexed. Well, sorry, that's not. Bash has 2 kinds of arrays. The kind of array that I'm going to talk about in the course are the integer indexed arrays, right? So they sort of look like Java arrays. There are some differences. Bash also has what's called an associative array. So that looks like a Java map or a Python dictionary, right? So you don't have to use an index, an integer index to get an element from an array. You can also use a string, right? So those look like dictionaries, Python dictionaries. I'm only going to talk about the indexed, the integer indexed arrays. But if you can use a Python dictionary, you can use a Bash associative array, right? It's no problem. Okay, so indexed arrays in Bash are weird. So they are zero based, right? So that means 0 is the smallest index that you can use, right? So there's no negative index. It doesn't mean that your array is actually indexed starting at 0. It just means that 0 is the smallest index, right? There's nothing from stopping you from making an array and starting indexing the array at 12, for example, right? So there's no requirement that you start filling in the array starting at index 0, right? And there's no requirement that your indexes go in order, right? So you can go index 1, then 17, then 247, then 356, right? You don't have to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You should probably go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? But there's no requirement that you do so. Okay, so if ARR is an array variable, right, then to assign to the array, it's the exact same as in Java or a Python list, right? ARR square bracket integer index square bracket equals and then your value, right? So for example, that line there makes an array variable ARR, sets its first element at index 0 to the string hello, right? So if you want to do assignment, right, it looks just like that. If you want to get the value out of the array, that's where things become a little bit more complicated. You have to write that, right? So you have to use the braces to get to the variable name, and then you use an index to get to the value. So a dollar, brace, array name, and then the index inside square brackets, right? If you leave the braces off, that's an error. Well, it gives you something funny. So that prints out the string hello, to no one's surprise. Right. If you forget to leave off the braces, you end up with, oh, hang on. If you leave off the braces, like this, in this particular, oh, so now you get something weird, right? So if you leave off the braces, the value of $ARR is the value that's sitting in the array element sitting at index 0. I believe it's always 0, even if you don't start filling in the array at index 0. Right. So that expands to whatever happens to be at index 0. So that's the string hello. The rest of it is treated as though it's just a plain old string. Right. So that does string concatenation, and you get hello square bracket 0 square bracket. So watch out for that. Right. Oh yeah, so this is the case here. So here I'm going to unset my array variable ARR. Right. I'm going to make a new variable ARR and set the element at index 5 to weird. And then I'm going to access the array incorrectly by writing $ARR. Right. Notice that you get the blank, the empty string here. Right. So the element at ARR 0 is nothing. It doesn't exist, so you get the empty string. Right. You don't get the first element of the array, which is sitting at index 5. Right. So weird. Right. If I then go ahead and set ARR 0 to strange, right, and then again incorrectly access the contents of the array, or I end up getting the the element of the array at index 0. So now I get strange. Right. If I really wanted to get the element at index 5, then you should put it in. Then you have to put it inside braces and access the element that way. Right. And so now you get the string weird. Right. So again, notice that that doesn't cause an error. Right. It automatically defaults to the element at index 0. Oh yes. So if you don't put the braces in, then then $ARR square bracket something expands to the string ARR at index 0, followed by the string square bracket I. Right, so now you get the string square bracket I. So remember, use the braces when you're accessing the elements of the array. Okay, so if you want to, you can declare a variable to be an array, right? So you can say declare and then minus AX, right? And so all that does, it says that X is a variable that's supposed to be an array. It doesn't mean that X is actually an array. You can still use X as though it were a plain old variable, right? So declare doesn't really do anything, anything particularly useful, right? To create an array, you can, if you create an array, you can also initialize the elements of the array using round brackets. Right. So y equals round brackets 10, 20, 30 makes an array y of length 3. It sets the element at index 0 to 10, the element at index 1 to 20, and then the element at index 2 to 30. Right. So that will print out 10, 20, 30. Right. Again, notice that to access the values of the array, I'm using the braces here. Right. You don't need the declare. So delete that. It's still going to work. Right. Right. You can always use the round brackets to make an array, to create an array. Right. So AR1, round brackets, hello, makes an array of length 1 whose contents is hello. Right. That makes an array whose contents are 0, 1, 2, 3, and 4. Right. So if you don't put in any indexes when doing this, it starts counting at 0, goes up by 1 each time. If you want to be explicit about the indexing, you can use this syntax here. So ARR3 is an array. Element at index 1 is the string goodbye. There is no element at index 0. The order of your elements of the indexing doesn't have to be there's no requirement on the order in which you use the indexes. Furthermore, the indexes don't have to be contiguous, right? So the element at index 100 of ARR4 is the string weird. The element at index 0 is the string weirder, and the element at index 1 is weirdest. There's nothing at index 2, there's nothing at index 3, there's nothing at index 99. Okay. That works, no problems, right? And if you wanted to, you can go ahead and try to print out the individual elements, and you'll get exactly, well, you'll get what you expect, or what you should hopefully expect. Okay, so that's how you create an array, right? If you need to create an array, round brackets, and away you go. Right, or declare if you want to. What else? I guess there's other ways to do this as well. Let me insert a new cell. Insert cell below. Okay, ARR5. So if you just use the square brackets to assign to an array element, this also makes an array. Oops, sorry. Oh, ARR5, sorry. There you go. Right. So ARR5, the element index 0 is the string OK, right? And then ARR5, the element index 1 is good, and then ARR5, the element index 2 is fine, right? So if you just use the square brackets, that automatically creates an array as well. Right? I'll explain the at notation here in a minute. Right? I just did that there so I could print out the contents of the array in one line. So I'll explain that in just a moment. All right, so if you want the number of elements in the array, then again, it's a funny syntax. Right, so to get the number of the elements in the array, it's very wordy. So you need to access the array, right? So $. Whenever you access an array, you're using braces. So we need the braces, right? You need the name of the array. So there's the name of the array, right? You now have to use this funny notation, square bracket at square bracket. and the number sign is in front of the array name. Right, so it's awkward to get the length of an array. Right, so remember dollar brace number sign name of the array square brackets at. Right, which is a lot to write and a lot to remember. If you run that, right, so that's the number of elements in array 1, so that's 1. Number of elements in array 2, so that's 5. Right, there's one thing here, there's 3 things here. Right. So what the heck is this at? And guess what? There's also a star. Right. So just like you use at and star here, you can do something similar with arrays. Right. So $, brace, ARR at, and $, brace, ARR star, those are both expansions, right? They're similar to this expansion here, right? So both of these strings expand to $. So the first element of the array, space, second element of the array, space, third element of the array, and so on and so on and so on. Nothing is quoted here, right? So if you use the unquoted ARR at or ARR star, right, then you just get the list of array elements. Nothing is quoted in that list, right? Which is fine if you know that there's no special characters in any of your array elements, right? That might work for you. Right, so either expansion is fine if you know for certain there's no unusual characters in your array elements, right? Or you have unusual characters and you want them to be treated in a special way. Okay, so just like that results in the sequence of command line arguments all quoted, right? The quoted version of ARR at produces the quoted sequence of array elements, right? So $ARR at all quoted gives you the sequence quotes, $AR, the first element of the array, second element of the array quoted, third element of the array quoted, and so on and so on and so forth. Right, so each element is expanded as though it were a single string. That's almost always what you want to do. Right. You can also write ARR star in quotes, right? So the effect of that is to produce this string, right? So same as this, and then quote the entire string, right? So you get that string and everything's quoted. So you get back one string, right? Which might be what you want also, right? So for example, if you wanted to print the contents of the array, you could just use you can just quote $ARR star, and that will print the contents of the array on one line, right? Which admittedly is handy if you're debugging or if you want to print the contents of the array for some reason. Okay, so the following 4 examples all illustrate the differences between the expansions, right? So here I've got an array. It has 3 strings in it, right? So it's got the string a dog, a cat, and a fish, right? So I'm going to use the unquoted star, right? And print out each element on a line, right? So if you use the unquoted star, right, you get a dog, a cat, a fish all on one line, right? So you get the list a dog, a cat, a fish, right? When you split that sequence, right, you get each word in that sequence, right? So in other words, a dog, a cat, a fish, right? So $ARR star expands to a dog, a cat, a fish. Yeah. Right, and now when you run your for each loop over that, it processes each word of the result of the expansion. The unquoted the unquoted at does the exact same thing. I guess this is an edit. Right. So both of these produce the same expansion. Right. If you quote, right, now you get a dog, a cat, a fish on second line. that produces the quoted a dog, the quoted a cat, and the quoted a kitten. Right, and then finally, the last one, you get one line. Right? So the last one is all of that as one string. So when you process that, you just hit the one string. I guess I have to stop because it's 20 after. So don't forget, you got a quiz on Friday. Right, topics are on OnQ under the announcements. I'll post the first two assignment solutions. Well, the first assignment solution today, the second assignment solution tomorrow, or at midnight tonight.
Yeah.
What's up?
Yeah, because on one of the practice questions for the quiz.
Yeah.
What output?